Hello, this is Mr. Henry, and welcome to lesson 0.3. In this lesson, we are going to compare and order rational and irrational numbers. So we know what rational and irrational numbers are. We are able to evaluate them, simplify them, and then determine if they are or are not rational numbers. So now what we're going to do is figure out, how to figure out which one's bigger and smaller, put them on a number line, things like that. The essential question says, how do I compare and order rational and irrational numbers? Did you know the square root of any non-perfect square will always be irrational? That means if you take the square root of something like, say, 7, 7 is not a perfect square. If I take the square root of it, their second square root 7 equals a decimal. If you take the square root of a big ugly decimal, or I'm sorry, if you take the square root of a number and you get a decimal, it's always going to be irrational, this big, huge, ugly decimal. So square root of 7, square root of 8, it's an ugly decimal. Square root of 9, not. Square root of 9 is a perfect, or it works out perfectly. This is rational because 9 is a perfect square. All right. It goes on to say that between any two numbers, there is actually an infinite number of irrational numbers in between them. So, for example, between just the numbers 1 and 2, so if you look at 1 and 2 on a number line, number 9, 1, 2, you have the square root of 2, square root of 3. 3 square roots of 2, 3 square roots of 3, 3 square roots of 4, the cubed root of 5, cubed root of 6, cubed root of 7, the fourth root of 2, the fourth, like all of these are different decimals. And they would all fit in between here and here on a number line. As well as some funky decimals, like I could just make up a bunch of decimals if I wanted to, like right in here. I could come up with a decimal 1.68324197783, and I could just keep making up numbers. That would be an irrational number. Okay. This lesson does not have any new vocabulary, so yay us. So example 1, they would like us to plot each point on the number line. Okay, seems reasonable, easy enough. We're just going to take these 4 numbers and put dots and label them on the number line. Okay, so looking at these 4 numbers, I personally am going to just do the easy ones first. So I see 10.8. Well, if here's 10, here's 11. Now, I'm going to throw an extra couple of lines in here just to make my life a little bit easier. 10.5 would be right here. So this is maybe like 10.6 or 10.7. So 10.8 will be over here. So I'm going to call this line right here 10.8. Now, let's see. These other guys. Got 10 and 1/9 and 45 fourths. Well, 10 and 1/9. 1/9, we learned this in one of the previous lessons, that 1/9 would be, since this is a denominator of just 9, we're just going to have the same number up top repeated over and over and over again. So this would be 10.11111111 repeated. Okay, so that would be like over here. This is 10.5. 10.1 would be about here, or close to it. So I'm going to call that guy 10 and 1/9. Trying to squeeze it in there a little. Got to put all 4 of these in there. There's 10.8. There's 10 and 1/9, which is 10.1. Now these other two, a little bit uglier. We'll do the 4 square roots of 8 first. Square 4 second x squared, to get our square root symbol, 4 square roots of 8 equals. Now, reminder, that is saying 4 times the square root of 8. That's how we get this exact same answer. All right, so I'm looking for the decimal of approximately 11.3. That is 11.3. So over here, 11.3. Well, if this is right here is 11.5, 11.3 would be around in this ballpark. Now, I haven't actually said it yet. What is the scale they're actually counting by here between 11 and 12, between 10 and 11? Like, what are these actual little lines? Well, it's not that bad. If this is 11, then this one, there's 3 sections between 11 and 12. So these are broken down into thirds. So this is 11 and 1/3, 11 and 2/3, 11 and 3/3 would actually be 12. So this technically would be the decimal 11.3 repeated, 11.6 repeated. That is 11 and 1/3. This other one would be 11 and 2/3. I don't need them to write them in there for the problem, but it's helpful to understand what are the little lines there. So when I'm trying to put in the number 11.3, I know it's going to be just a little bit less than this line. Okay, so I'm going to erase these guys. I don't need them. But I know this 4 square roots of 8 is going to be like right here somewhere, just a little bit less than my line. 4 square roots of 8. Okay, last one is 45/4. So change a fraction to a decimal. Divide. 45 divided by 4 equals 11.25. Okay, so if this was 11.3, this guy's just a teensy bit smaller. So I'm going to go just like over here a little bit. I mean, it's probably honestly a little bit closer, but I needed the space, so I had to scoot it over a little bit, or else these two dots would be almost on top of each other. Okay, so I'm going to call that guy 45. Okay, so we found the location of each of these points, and we placed them on the number line. We labeled them. I didn't label them as like 11.3. I labeled it back in the original form. Make sure you do that, okay? Because in a second here, you folks are going to be doing letter B. Notice it's a different scale. Here's 12, skip a space, 14, skip a space, 16, skip a space, 18. So it might be helpful for you if you throw in what is in between here as you're going to try to plot these 4 points. So what I'd like you to do is pause the video, try this on your own, please. When you're ready to continue, or if you get stuck, hit play, and we'll go through it together. Okay, so let's see how you did. Well, hopefully you saw that this number written here would be 13, 14, 15, 16, 17, 18, right? So we're doing a pretty good just guessing approximation here. So I'm just going to go across the row here. So square root of 156. Second square root, 156 equals 12.489. So that's almost 12.5. Okay, I'm never going to get exactly 12.489996 in this little number line. So I'm just going to get it close. In my mind, that approximating is 12.5. So I'm going to put pretty much right between 12 and 13 right here. I'm going to say that is the square root of 156. Next one, 14 and 2/3. That's going to be 14 point something. So I know I'm already between 14 and 15. Now, 2/3, hopefully you know by 8th grade, 2/3, 2 divided by 3, is going to be 0.666666666. Remember, calculator rounds. So this would be 14.6 repeated. So in between 14 and 15 is 14.5. So I'm going to go just a little bit over here and call that my 14.6, my 14 and 2/3. Okay, next one, 178 over 10. 178 divided by 10 equals 17.8. So 17.8, 17 and 18. If you're trying to figure out like which side it's closer to, it's definitely closer to the 18. And I'm just going to ballpark it right around here. Probably a big dot. Didn't need quite such a big dot, but that's okay. So I'm going to call this guy, that's 178 over 10. Just label that little dot there. And the last one, 4 square roots of 15. All right, all right, all right. 4 times second square root, second x squared, square root of 15 equals 15.49. Now that's also almost 15.5. I'm approximating. So between 15 and 16, right about here, that is to be 4 square roots of 15. So I like my dot black since I made the numbers black. This guy goes here, this guy goes there, there. We're all lined up. There's a little line in there. It's a little hard for me to see. If I switch to black. Okay. So hopefully you're seeing a pattern in what we did in each of these. We took whatever number it was, and we evaluated it. Basically, we changed it into a decimal. Decimal, 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 decimal. Some of the times, we approximated. This was not 12.5. It was 12.489999996 something. We approximated what it was to put it on the number line. Very, very, very rarely will you get an exact answer that you can put exactly in the number line. Most of the times, you're just looking for where is it close to. All right, even the 17.8 right here, that's probably not 0.8. That might be 0.7893, whatever, garbage. You just got to be close. Okay? Change it to a decimal. Find the approximate location of the number line. Let's try 2 more. So letter C, we're going to go through this one together right now, and then you guys are going to try letter D. All right, so I have the negative square root of 3 over 2. So calculator this thing. Here's how I would type this in. I would not try to type this as one thing altogether. I would find the answer to the top and then hit divide 2. So I'm going to take negative second square root of 3. It's going to take the square root of 3, throw the negative in front. See? Now, I'm going to take that from here, and I'm just going to hit divide 2. I'm not going to try to write that down on my paper and then recopy it in there. Just hit divide. So it takes your answer, divide by 2, equals 0.866. Okay, so I'm going to write this down, at least close to it. So 0.866. Negative, ooh, I forgot the negative. Negative 0.866. I really screwed up that 8. That's good enough. All right. So here's my number line. This is 0. Since I'm looking for a negative number, I know I need to go on that side to get to negatives. That side is my positives. So I'm looking at the scale. There's 3 spaces between one number and the next. So this is again counted by 1/3. So this would be right here, negative 1/3, negative 2/3, and negative 3/3. See how it's negative 1? Negative 3/3 is the same thing as 1, or negative 1. All right, so to help me imagine what these numbers are, negative 1/3 is negative 0.3, repeated. Negative 2/3 is negative 0.6, repeated. So I'm looking for negative 0.8. So I know I'm going to be closer to negative 1. I'm down in this ballpark. So I'm going to go ahead and throw a dot in here. And I'm going to call him negative square root of 3 over 2. Okay, so that was a lot of work just to get the location of that one. But it's worth doing that extra work to make sure you get it right. Next one, 0.5. That's actually pretty easy. Stays positive. See, positive. So halfway between 0 and 1, right here, is 0.5. Okay, nice. He was already a decimal. Loved it. 0 divided by this stuff. Okay, now, I know what this is off the top of my head, but maybe you don't. So what you're probably doing is you're going to take 0 and you're going to figure out what this junk is on the bottom. You're going to type it into the calculator, and you're going to hit 0 divided by that stuff. So here's how you do that. Here's how I would do it. So 8 square roots of 6. This is the answer to the bottom of our fraction, is that. Now, in order to take 0 divided by that without having to write down everything, I'm going to take 0, divide, and I want to get the answer from the previous prompt. So I'm going to put second, and look right here. There's this little answer button right there above the negative sign. 0 divided by my previous answer is 0. Because 0 divided by anything is 0. I didn't have to go through all that work, but maybe you didn't know that. Maybe you didn't know that this was going to give you a 0 for an answer. But it does. So now we can say, okay, this is going to be right here, right at 0. I'm going to have the point 0 over 8 square roots of 6. Last thing I'm looking for here is -1/9. Now, that is a repeating decimal. The denominator is just over a bunch of 9s. 1 9 in this case. So this decimal is going to be -0.111111111, repeated forever. The space. So now, if this is -0.3, -0.6, -0.1 would be really darn close to 0 on the negative side. So, ballpark in here somewhere. I'm going to say this is my -1/9. Okay, so we're getting close. Not exact. We need to be within reason. If you're within about, like, say, that distance of where it actually should be. I mean, I'm within that distance of 1/9. 1/9 is around here somewhere. I'm pretty close to it. I don't have to be exact, and neither do you. All right, letter D. This will be another one for you to try it out. If you take a quick glance here, you'll see all your numbers are negative. Let that sink in. Go ahead and take each of these and try to find their approximate locations on the number line. Pause the video, take your time. When you're ready to continue, hit play, and we'll go through it together. Okay. So let's do, well, first one, -5.832. It's already a decimal, so I don't need to convert anything here. If this is -5, -5.8 in my mind is pretty darn close to -6. It's closer to -6 than it is to -5. So if this is my span, I know -5.8 is going to be more on this side over here. Now, technically speaking, this would be -5.5. It's halfway between the two. 5.5 is here, so -5.8 would be, I don't know, even a little bit closer than halfway. So I'm going to say right about there. Call him. Do it up higher. -5.832 is there. Next one is negative square roots of 60. I have a good estimate in my head, but I'm not sure. Negative second square root 60 equals -7.74. -7.7. Honestly, that's as close as I need to get. Putting down the 4, 5, 9, whatever, is not going to get us any closer. It might just confuse us more. So -7.7. Again, this guy is closer to -8 than -7. So on my number line, I'm going to be looking in the more closer to the -8. I'm in this area. Now, if this is -7.5, this is 8, I'm going to be kind of in the middle, right? This is 7.5, 7.6, 7.7, 7.8, 7.9. Like, didn't space them out right, but they're all in there. Negative 7.7 is kind of right there in the middle. Okay, negative 6.3 repeated. Now, it is repeated, but we don't really need to worry about all these extra 3's because we don't have that accuracy just drawn by hand anyway. So just kind of ballpark it. So as I'm estimating here, this negative 6.3, he will be closer to negative 6 than negative 7. So between these two, negative 6.3, I would say is, well, this is negative 6.5 or 3 there somewhere. Last one, negative 5 times the square root of 1. Okay? Negative 5 times the square root of 1. Now, maybe you already knew the square root of 1? Maybe not. It's 1. 1 times 1 is 1. So if you square root 1, you get 1. In that case, you get, since the square root of 1 is just 1, took that times by negative 5, you saw what we got. 5. So right here is my square root of negative 1, and, I'm sorry, the negative 5 square root of 1. It's just exactly negative 5. So again, we changed everything into a decimal, then put them in their approximate locations on the number line, making sure we're paying attention to which numbers we should be closer to negative 8 or closer to negative 7, closer to negative 5 or closer to negative 6, understanding the scale they used. Example 2. Put each set of numbers in order from least to greatest. So I'll be honest with you, we just did that in the last set. Check this out. I had 4 numbers in random order. After I put them in the number line, I can say, well, this is the smallest, and then this one, and then this one, and then that one. Now they're in order from least to greatest. Same here. So the process we're going to use is the same. We're going to take each of the numbers here from these problems. We're going to change them all into decimals. And then once there's decimals, we're going to put them back in order in the original form, and we're done. So this is just going to honestly be a lot of calculator work here. So first one, square root of 17. Now, if we said no calculator, this then becomes a hard question. Because then you have to worry about, like, what is the square root of 17 in your head, which we will get there, just not quite this lesson. So calculator me here. Let's see. So square root 17 is 4.123. Okay? I doubt I need all those decimals, but I'll go that far, I guess. Okay. I know what he is a decimal. Ooh. I know what this is a decimal. That's 3.89. I know what this is a decimal. That's 0.1 repeated. I'll be honest, I know what this is a decimal. I've done square root of 9 a whole bunch of times in the past few lessons. That's just 3. And 9 halves, I know what half of 9 is. If you don't know, the way you change a fraction to a decimal is you divide. 9 divided by 2 is 4.5. 5. All right, so now we have them all in order. I'm sorry, I lied. We have them all as decimals. We need to put them in order. So we need to get a little, figure out which of these is the smallest. We're going from least to greatest. From least to greatest. So when you're comparing decimals, you always look at the whole number first. So I have a 4 point something, 4 point something, 3 point something, 3 point something, 0 point something. Out of those, clearly the 0 point something is the smallest. 0 point something will always be smaller than 4 point something. So the smallest one was 0.1 repeated. Okay, that is the smallest. Now, out of the next 4, these two start with 4s. These two start with 3 points. Their whole numbers are 3. So I got to decide which of these two smaller? Is it 3.8 or 3.1? I'm sorry, that's not a 1, that's a comma. Let's make him prettier to see. That's a comma. This is actually 3.0. That was from the number square root of 9. So 3.8 or 3.0? Well, 3.0 is smaller than 3.8. Square root of 9. Notice I'm using the original number. You should do that too. Okay, out of these three, I know this is going to be the next smallest because these two start with 4 point somethings and this is a 3 point something. So 3.89 is the next. All right, these two both start with 4 point somethings as decimals. So is it 4.1, 4.5 smaller? 4.1, 4.5. Yeah, it's 4.1. 4. Whoa. Not putting down the decimal, putting the original number, which was square root of 17. And that means that 9 over 2 is last. So I took each number, I changed them all into decimals. I then figured out which was the smallest number, and I wrote down the original form. And I kept doing that until I ran out of numbers, until I got to the biggest one. I'm doing the same process again here for letter B, and then you're going to have a couple for you to try. No, I guess one down there. So, well, he's already a decimal, so I don't really need to worry about him. It's 8. That is an ugly, ugly 8. I'm going to try it again. 8.43. Now, I know that goes 4, 3, 4, 3, 4, 3. Okay? I'll keep that in mind in case I need it. I know this 8.1 as a decimal is just 8.1. These two, well, I'll pretend I'm a little unsure about. This one I can probably get you pretty close. This one, not as well. So let's figure it out here. 8 and 3/5. Well, I know this is going to be 8 point something, because that's the whole number. The whole number is 8. But the decimal, 3/5. 3 divide 5. That's how you change a fraction to a decimal. You divide. It's 8.6. All right. Square root of 80. Second square root 80 is 8.94. That is by far the biggest of these. 8.94. Okay, so we have them all as decimals. That's the first goal. Now we need to figure out which of these decimals is smaller. Now, it doesn't really help us that they all start with 8 point something. They all have the same whole number. So the whole number is not going to help us here. We have to go on to the first digit. We go one digit at a time. So I have 8.4, 8.6, 8.1, 8.9. The smallest of them would be 8.1. I'll put him down first. 8.1 is the smallest of these. Now, next smallest would be 8.4, 8.6, or 8.9. It's 8.4. 8.4. Peter, remember put down the original form? 8.6 or 8.9. Hopefully you're saying 8.6 is next, this 8 and 3/5. And that leaves lastly square root of 80. Is our largest. Took the numbers, decimals, back to the original form. Alright, here is letter C. If you could, please, I'd like you to pause the video, try this problem right now. When you are ready to continue, hit play, and we will go through it together. Alright. So, decimals. This is 4.9. This is 4.1111. And the other ones are not quite as easy, so let's see here. Second square root 20 is 4.47. Okay, 4.47. All right. 2 square roots of 5. 2 times the square root of 5 is 4.7. Now, I doubt that these two things are identical. More than likely, what I need to do is I probably need to just get a couple more decimals. So 4.47. What this? I'll write down the whole thing. 4.4721. 4.4721. 35955. 35955. All right, let's do that first one again. So this is 2 square roots of 5. 4.472135955. All right. Back over to the square root of 20. 4.4721. Huh, would you look at that? These two are identical. So as we're putting them in order from least to greatest, I guess it doesn't really matter which one you put first because they're the same number. They're identical. Tricky, tricky. So those two are the same. And I'll just leave this down here. I know it's 4.47 again. All right, 4 1/10. So I know it's going to be a 4 point something because that's the whole number. 1/10, I've got to figure out. 1 by 10 is 0.1. Uh-oh. These two look like the same. It's like those two are the same. But they're not exactly. Here's the difference. This one is 4.111111 repeated. This one is 4.1 done. There's nothing else. Now, if you wanted to throw an extra number out there, you could throw a little ghost 0. But you don't need him. Okay, so these two are not actually identical. They look close. That's the trick here, is it makes you think it's the same thing, but it's not. This one is actually smaller. 4.10 is smaller than, I'm sorry, yeah, I was right. 4.10 is smaller than 4.11. All right, so order from least to greatest. Smallest of these, 4.4, 4.9. 4.4, 4.10, or 4.11. 4.10 is smaller. 4.4, 4.9, 4.4, or 4.1. I'm just really looking at the first two numbers, the whole number and the decimal. 4.1 is smaller than 4.4 or 4.9. 4.1 heated is next. We learned earlier that these two, square root of 20 and 2 square roots of 5, are actually identical. Identical. So it doesn't matter which one we put first, I suppose. So if you put square root of 20 first, awesome. If you put 2 square roots of 5 first, hey, more power to you. Doesn't really matter. They're the same thing. Which means 4.9 is the largest of those. Okay, letter D, one more for me. Same dealio. Put them in order from least to greatest. All right, looking here, I don't start out with any decimals, which is kind of a bummer. I liked doing that. But I guess since I really wanted to use my brain here, this guy I know it's going to be -3. In fact, I know, well, actually, no, I lied. I was going to say that this starts with a -3 point something, but I don't know that. I know this one starts at a -3 point something, because that's the whole number out front. And 7/9 is that repeated decimal. 7777. So this becomes -3.7 repeated. And that's as far as my brain's going to carry me today. All right. -3 times the square root of 12. I'm doing this first one. -3 times the square root of 12 is -10.39. -10.39. Alrighty. Next one. Square root of 20 divided by -2. I'm not going to type it in at one time. I'm going to do second square root 20 equals, get an answer. Now hit divide -2. Now I'm curious, so let me write this answer down first. -2.23. That was supposed to be my negative sign. I'm curious, if you just typed in this whole thing at one time, if the calculator would give you a wrong answer. Watch this. Second square root 20 divided by 2. Domain error. Now, I actually know why the calculator does this, and it's baffling to me, on as smart as these calculators are, that they can't do this. The problem is the calculator does not like having a negative sign on the bottom of the fraction. It gives you an error message because of that. That is, well, I lied actually. It thinks this -2 is inside the square root, and you can't take the square root of a negative number. But this is also a problem. The calculator doesn't like having negatives on the bottom. So one way we can fix that is if we just throw the negative out front. Oops. Throw the negative out front. We're still going to get a wrong answer. If we just pretend like this negative is up here instead of down here, it's still not even the right number. 3.16 versus 2.23. So let this be a caution. Don't just throw everything straight into the calculator. The calculator cannot be your brains. Okay? You have to kind of show the calculator exactly what you want done. Do it one piece at a time. The calculator is smart enough that you can do this thing like do second square root of 20 equals. Now divide. Look, answer divided by -2. So it's taking the square root of thingy divided by -2, and we get ourselves an answer. Okay? Try it like that. Don't just throw the whole thing in the calculator. It's gonna mess up from time to time. Fourth one. Negative square root of 33 over 8. All right, so negative square root of... Now, this 33 over 8 is as a fraction, so I could actually do fraction. 33 fraction, your fraction button looks different than mine. Fraction 8. And close parentheses if we want. I don't think it really matters. And it gives us -2.03. And again, that was my negative. All right, so we have them in decimals. So now we got to go from the least to the greatest. Now from here, I have to make a decision. What is smaller, -2 or -10? A lot of people would go with -2. They're wrong. -10 is smaller because there are more negatives. The more negative a number is, the smaller it is. So in this case, -10 is actually the smallest. If you have a number line, boom, boom, here's 0, -1, -2, all the way down here, you'd have -10, 2, -3, -4. This way is smaller. -10 is smaller than -2. It is more negative. It is further away from 0. Now, to put you in a little secret here, these four numbers are actually already in order from least to greatest. Look at this. -10. Next we have 3. Next we have -2.2. And then lastly, -2.0. These are already in order. I didn't have to do anything, but I didn't know that at the beginning of the problem. I mean, look at them. Those are ugly. The only way I was able to figure this out was by doing the problem, was by actually taking the square roots and fractions and all that kind of good stuff. All right. Here are the last two of this type of problem for you to do, letters E and F. So if you could please pause the video, try these two problems on your own right now. When you're ready to continue, hit play, and we'll go through them together. Okie dokie, that was a terrible straight line. So, we want to try letters E and F. So I see here this is already a decimal, so I'm just going to copy him down. I know what this is because I'm a smart individual. This is 5.04 repeated. Check this out. 4 divide 99 is 0.040404. I knew it was going to be a repeated decimal because it was over 99. Just like I know that this is going to be a repeated decimal because it's over 9. Now, I could figure out what it is, but let's calculate it. 53 divided by 9 is 5.88888888. Calculator rounds. Ignore him. So 5.8 repeated. Square root of 95 thirds. Clear, clear. Second. Square root. 95 fraction 3 equals 5.627. All right, they're all decimals. Smallest. So I've got 5.0, 5.6, 5.8, 5.3. Smallest being 5.0. 5.0 is smaller than 5.6, 5.8, or 5.3. So 5 and 4/99ths will be my smallest problem, my smallest expression here. Next smallest, we have 5.6, 5.8, or 5.3. Yeah, it's 5.3. Next two, 5.6 or 5.8. Clearly 5.6 is smaller. Hopefully you got the idea, and I don't need to go quite so slow. I think I'm done. It's the wrong number. I think I'm done doing baby steps through here. We need to pick up the pace. This video's dragging on. And 5.8 is obviously the largest, 53/9. All right, letter F. Decimals, negatives, negative 9.3, negative 3. I don't know what that is. I don't know what that is either. All right, calculator time. Clear. Negative 9 second square root 3 equals negative 15.5. Negative 15.5. And the other one says clear. Negative second square root. I know 9 divided by 3 is 3. I could just put a 3 in here. I'm going to get the same answers if you didn't trust me and you did negative second square root 9 fraction 3. You get the same thing. It's 9 over 3 is 3. Either way, negative 1.7. All right. 4 numbers. They all have different whole numbers, which makes this very easy. The only thing that makes these trickier is they're all negatives. And so you got to know that negative 15 is the smallest because it has the most negatives. So we have negative 9 square roots of 3 is the smallest. Then we have negative 9.3 is the next. Then we have negative 3 or negative 9 over 3. And then finally, negative 1.7 is the closest to 0, which makes him the largest of these numbers. All right, we got a couple little problem solving, and we're out of here. So it says, for homework, Anthony's math teacher gave him this list of numbers. Aren't they beautiful? His teacher asked him to identify the smallest irrational number. Help Anthony by showing how you would do this problem. So we're looking for the smallest irrational number. Okay, that's kind of a very loaded statement there that you got to really understand and figure out what the heck they're talking about. So clearly we know what the smallest means, and we should know what an irrational number is. So you got to figure out which of these are irrational, and then from them, find the smallest one. Well, this is not irrational. That's a nice, pretty decimal. He's rational. So I can ignore him. This one is rational. It's already a fraction. And my fractions don't have any weird things in it. There's no decimals, there's no square roots, there's nothing. This is rational. I don't need him. This one Yes, it looks like a fraction, but you see the square root of 8? That does not count as a fraction anymore. Fractions have only whole numbers. You can have negatives. You can't have decimals, and you can't have square roots. So we're going to ignore him for a second because this guy's not a whole number. So let's do the other 3 here. Clear. 4 second square root 34 is... Okay, that is irrational. 23.32. 23.32. That is an irrational number. Keeps going forever. And it's pretty big. Next one. Negative square root of 4. Might know this already. If you do, good for you. The square root of 4 is 2. With the negative out front, makes it a negative 2. Which means that is rational. That's a nice, pretty number. Rational, throw them away. 15 over square root of 8. Now, I'm going to do this 2 different ways because I'm not sure if the calculator is going to do this right. So I'm going to take 15 divided by the square root of 8. Actually, I'm pretty sure the calculator is going to do that right. The other way to do that is if you're unsure. You can take the square root of 8 and then say, okay, I want to take 15 divided by my previous answer, second answer. And if it works out right, I should still get the 5.3. But I didn't. Oh, because I hit multiply. Second square root. I'll take 15 divided by the previous answer. It should be the 5.3 thing. Yeah. All right, so that's an irrational number. And it's 5.3 something. So, teacher asked him to identify the smallest irrational. These 2 are irrational. This one is the smallest of them. So 15 over square root of 8. And help Anthony by showing how you do this problem. Well, there's all my beautiful work. I showed which ones are rational. I showed the decimal expansions of the irrational numbers. I can't really see that one. Go. And therefore, we can identify that that is the smallest irrational number. Letter B. Jasmine has 2 3/4 dollars. Kayla has square root of $5. Trisha has 2.9 repeated dollars. And Kaylani has 37 over $20. If these girls need a total of $11 to buy a board game they want, would they have enough money? So I got to figure out if these 4 girls, if we combine their money together, right, take Jasmine's money plus Kayla's money plus Trisha's money plus Kaylani's money. If I add that all together, do I have at least $11? If I have at least $11, if this amount of money is bigger than $11, then they can buy it. That's kind of what we're trying to figure out. So Jasmine has 2 3/4 dollars. Kayla has square root of $5. Trisha has 2.9 repeated dollars. And Kaylani has 37 over $20. I do not recommend just trying to type this whole big, huge monster into your calculator. It is going to be so confusing for the calculator to understand what the heck you're trying to type in. Do them separately. 2 3/4. You know it's going to be 2 point something. And hopefully by now you know 3/4 is 0.75. 2.75. Square root of 5. I don't know that either. Just do it on the calculator. We get 2.23. Now, since we're talking about money, we're only going to keep 2 digits after the decimal. And we should probably round the third. So this is 2.23, but that 6 after the 3, it's bigger than 5. So that 3 is going to round up. So I'm going to call this 2.24. 2.2. Trisha here has 2.9 repeated. So that's 2.99999. So if I'm going to round to this digit, look the next guy over, he's going to make this 9 go up. So instead of $2.99, if I would chop it off here, this goes up, it's going to go up to $3. So she has $3. And last one is 37 over 20. 37 divided by 20 is 1.85. Beautiful. Nice, pretty decimal. All right, so they're all as decimals. That makes it easy now. I can type this in the calculator, and the calculator is not going to get confused. 2.75 plus 2.24 plus 3 plus 1.85 is $9.84. If these girls needed a total of $11 to buy a board game they want, would they have enough money? No. They're short by over $1. They need more money. All right, so example 3. A carpenter needs a piece of wood that is very close to 4 feet long. The pieces of wood he currently has are those 4 lengths. Which of those pieces of wood is the closest to exactly 4 feet long? So what I'd like you to do is I'd like you to pause the video, try this problem right now, and when you're ready to continue, hit play, and we'll go through it together. Okay, so hopefully the first thing you tried was to take all of the numbers and change them into decimals. Because they're kind of a really mixed bag of numbers, that's probably the easiest way to compare them. So I'm just going to take each of them one at a time, and I'm going to change them into decimals. Boom, 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 boom. Starting with, here, 8 divided by 3.1. Okay, that's 2.58. 2.58. That's fairly far away from 4 foot. So I'm kind of certain already that that's probably not going to be the answer, since I can see this guy over here is 4.12. All right, next one is the square root of 17. That's also 4.2. That's 4.123. See how I had to be a little bit more accurate? And this one would be 4.1212, because it's 4.12 repeated. And the last one is going to be a 3 point. And I know that 8/9 is going to be 0.8 repeated. Done that a bunch of times. So out of these, which is the closest to exactly 4 foot long? Well, I know it's not going to be this guy, because he's clearly the farthest away. These 3 are all kind of close. So the way to figure out which one is the closest is to find out, well, what is the difference? The change. Subtraction is what we're going to do. So I'm going to take, and I'm going to do a little subtraction. So, well, I'll do this one first. Why not? If I take 4 minus 3 point, put a bunch of 8s in here. Right? Just a whole bunch of 8s equals. Okay, that's how far away he is. This number is 0.111111 away. That is his difference. Okay? This one is, well, I can tell you right now because I can take 4, subtract this thing in my head. This will be zeros. This is going to be 0.123 away. And same thing here. It's a 4. If I have a bunch of zeros in here and I subtract, I'm going to be at 0.1212 away. So out of these 3 differences, which one has the smallest difference, the smallest change from that number to 4? The answer is this guy. That is the one that is closest to 4. The answer is the 3 and 8/9 is the closest to 4. These other 2 are awfully close. Not quite as close, though. Letter D. In health class, the teacher measured all of the students and wrote down their heights on note cards. Sam's note card says 60 and 1/5. James's note card says square root of 3,600. Hank's note card has 8 square roots of 60, and Franklin's note card says 487 over 8. Arrange these boys in order from the shortest to the tallest. If you could please pause the video, try this problem on your own. When you're ready to continue, hit play, and we'll go through it together. Alrighty, here we go. So we've got Sam, James, Hank, and Frank. So Sam is 60 and 1/5. Again, I'm going to take each of them and put them as decimal. So I know that Sam is 60.2. James is the square root of 3,600. That is going to be exactly 60, I'm pretty sure. But I'm going to calculate just to make sure I don't make a bonehead mistake. Yep, it's exactly 60. Hank, I don't know Hank's. 8 square roots of 60. 8 times square root of 60 is 61.96. And lastly, Franklin's was 487 divided by 8 is 60.875. Alright, so I have these three here. So we're trying to put them in order from the shortest to the tallest. The shortest, well, the three ones that have a whole number of 60 out front, being this guy, and this guy, will be the shortest ones. Hank is automatically the tallest. So I'm going to put Hank last. I know Hank is the tallest. Now, out of the other three, this guy is a 60.2, 60.0, 60.8, which makes James the shortest. 60.0 is smaller than 60.2 or 60.8. So now between Sam and Franklin, we've got 60.2 or 60.8. 2 is smaller. Sam here, Franklin there. Last question, yay. Which number below would be located at point A on the number line? Okay, so we have point A here. We're trying to find out which of these guys would be about right there on the number line. So we got to examine this. We got to figure out what is this number. Now, between -5 and -6, right here, exactly halfway between, would be -5.5. So I know that point A is a number slightly bigger than, I lied, smaller, that way is smaller, slightly smaller than -5.5, just a little bit. So I'm looking for like a -5.6 or -5.7, something like that. Which means I can already eliminate a couple choices. I know it's not that, and I know it's not that. -6 and 1/4 would be out here.